Hello everyone, in this exercise of Solidworks, we will create a bevel gear and bevel pinion assembly. Eh, let's start. File, new, and assembly. Directly go in the assembly. This one. We will take the bevel gears from the toolbox here. This is the assembly window. I am cancelling this and also cancelling this one. Okay. Background I am selecting plain white and the unit system is a millimeter gram second. Okay. This is the task pane. In right side there is a task pane. In the task pane there is a design library. In the design library there is a toolbox here. Toolbox add in now. Click here. Now you will see there are the various standards here. You will find ISO, etc. I am taking ISO. This one. I am taking this standard. There are the various standards here. In the toolbox, there are various standards. I am selecting double click. And in this, there are the various types of the transmission devices and fastening devices also. So I am selecting power transmission, this one. And gears. In this one, I am gears, this one. These are the Bevel's gears. Here are the different types of gear, helical, identical, spur gear, bevel gear. There are two types of the gear, bevel gear and bevel pinion. Actually, pinion is the smaller one and gear is the greater than pinion. This is the pinion. Actually, pinion is smaller than the gear, whether it is in spur gear, whether in the helical. So pinion is a small gear. Okay. Actually, bevel gears are used for the power transmission purposes when the shaft on which they are mounted, they are parallel. Axis of the shafts are perpendicular at right angle. If the axis of the shafts are at right angle perpendicular, then they are used, not in parallel direction as in the case of the spur gears. Okay, so I am taking bevel gears. Click it and drag in this graphic area and this one. Okay, this is the first bevel gear. Now this window comes, properties of the gears are coming here. I am selecting, first there are the different properties here. Module I am taking 2 mm. Okay, number of teeth and pinion I am taking 30 mm. And this is the bevel I am taking gear. This shows the gear number teeth, 40 I am taking. You can take as per your requirement. I am taking 40 mm and 30 is the pinion number of teeth. Pinion I will later on select for with which this 40 gear teeth will meet. Okay, pressure angle 20, face width I am taking 12 mm. Half dia is this one. This is the half dia. Mounting distance I will show in the graphic area after assembly. I will show what is the mounting distance. Mounting distance is basically this taper line where we meet, is where these taper lines meet center point to the up to the end of the hub. This is the, I will show in the assembly when I will do the assembly later on. Mounting distance, this is the mounting half dia, this one. The half dia I am taking 30 mm and mounting distance is 50. I will explain you later. Nominal shaft die I am taking 12 mm. This is the shaft die on which the shaft is mounted. Keyway I am not presently you can use, but the key we definitely use the keys. But I am not. This show the teeth, 40 teeth. This is the gear, 40 teeth. Module is 2-1. Number of teeth is this one 30. Sorry. I am taking this gear is the. I am taking 40 teeth, not. I am taking 40 teeth. 40 teeth pinion I am taking. Pinion is at 30. This one 30. Okay. The pinion is taking 30 and 40 number of teeth of the gear. This one. Pressure angle 20, face width 12, half dia 30, and mounting distance is 50 mm. I will show you. And nominal shaft dia is this one, inside portion, and teeth is the 40. So this is the 40 gear teeth. Pinion is 30 number of teeth, which I will later on create this one and hit this one, the right button. this one. Now another gear is coming, but I am cancelling it. Okay, now I will take a pinion. Now I will take the pinion, this one, and this is the pinion, and this one. This comes here. Gear number 3, you will see pinion is automatically taken, 30 number of teeth. This is the pinion. Pinion is smaller as compared to gear. You please note this point. Pressure angle 20. Same pressure angle is to be selected as for the first gear. This is the first. This is automatically takes the combination makes here. So whatever requirement you can take. Now 30 number of teeth, the pinion teeth, this one, and 40 is the this one. Here earlier I have selected face width is 12 mm, this one, and mounting distance same, hub dia 30 mm, 12 mm face width, and shaft dia. Keyway I am not selecting. Show teeth. This is the 30 mm teeth. Okay. In this way I am taking this one. These are the parameters. You please note it. Gear teeth is 40, 30 mm teeth. This is the 30 mm teeth, and one more thing, that is a shaft dia. Shaft dia you will show here. Show teeth, keyway, nominal mounting distance, hub dia, face width, and this one. Hub dia is this one. Mounting distance 50 mm, nominal shaft dia is 15 mm. This is the inside portion. This is hub is this one. Okay, and I am hit the right button here. There the gear. This one. Now another gear also coming. This is also a pinion gear. I am clicking it, clicking in the graphic area. This one. I am cancelling this one. Escape key. Press select and delete. Yes, I am taking only 2 gears here. These are the pinions. Suppose I select it, right click, edit toolbox. You can see the properties window come here. This one. This one. 2, 30, 40 gear teeth, pressure, and 20. This one, same cheese, same thing. These are the 2 things. Okay. This one. These two gears. These 2 gears are similar. Okay. And this gear is 40 gear teeth. Okay. Now, this first gear in assembly, the first gear which is inserted in the graphic area, that is always fixed. This cannot move here. This cannot move. So how I can move it? Select it, right click, and float it. Now it can move. I move from here to here. Okay. Now first I will assemble all these three gears. These 2 gears are the pinion gears. This has the same configuration. This is separate gear. How I will assemble this one? I will assemble with the help of the mates, different mates. This is this one moving. First I am taking mat, and this one I am selecting this face and right plane here. Right plane, and I am making the relation coincidence. This one. This small window comes here. This one. Coincidence, and hit right button. This one. Now another mate, origin. This one, select this window, origin, and select origin, and this inside board. This one. This is not coincidence. You have to select concentric relation. Concentric, this one. Okay. Now same way, this face and this face, I am selecting parallel. These are parallel, and hit right button. Now same thing, origin, and this bore. This is concentric. So these 2 mates I have applied. One is the coincidence with the right plane, and second is the parallel, the 2 faces, and concentric with the origin. Both the pinions are this one. Now this one. Now this one, select this face, and top plane. Okay, but this window comes here, not coincidence. You have to take parallel. Face, you have to take the parallel, but flip the side there in this way. Okay, this relation. Now what I will do next, now you see carefully here. Now first bevel gear, first is this one, this bottom one, this one, and here you will see boss revolve, base revolve, you, and this boss base proscape, right click and show it, then this sketch comes here. Okay, in the same way for the another two gears, same thing, this one second, this one, and base revolve, this one, right click, show. Now this you will see these sketches comes here, this one, these sketches comes here. Okay, first these taper lines, actually these taper lines from both the sides meet at point. Okay, so first I will make the this, and you will see properly, see these taper lines where the teeth are inclined. So one point is this one, second point is this one, third point is this one. Okay, I will make the coincidence, made this one, and first I will make this one, this and this one, and coincidence. This point and this one, right, in this way. I have made the three, this one in this way. These two taper lines, have a point. One, this taper line has the one point. I have coincided these points. Okay, and this one. Now what will I will do? Now hide the sketches. This one, hide the sketches. This one, and second is the this one, base revolve. Hide this sketch. Hide this sketch. Now this is the hide. Now I will make the mate here. Firstly, I give the appearance all the three one. First one give from appearance here. This one, I am give the appearance here. This one, and second one. Second is this one. Appearance. I am give this appearance. Okay. Third one. This one. Appearance. I am giving it here green, this one, and I am giving yellow appearance in this way. For the demarcation purpose, I have given the appearance to all the three gears. Now I will make the mates here. I will apply the gear mate. Okay, how? Now, if I take the right view, this one, this is the right view. Okay, firstly, these two gears, bottom one and this one, I will place proper position. How I will make it? Normal, this one and this one. You please avoid the interference of these two gears. this one, okay, and you will see there should be no interference. And now apply matte, clear, mechanical matte, gear matte, and select this hub shaft, this one, this shaft, and this shaft. Now this is the shaft dia, 12 mm, but click here because this has the 40 teeth, this one, and this one, this has the 30 teeth, this one, and hit the right button, hit the gear mate, first gear mate is open. Now I will apply here left one, again this one, hidden, this one, this one, and this one. There should be no interference to check properly. Okay, now mechanical gear, okay, select the bore, this one, bore you or hub you both can be selected, this one and this one, first I have made this one gear mate, and now is this one. Okay, this die is the 40 and this die is 30. Okay, this one, and hit the right button. Now I have applied both the gear mate. If you will see, this will move. This one, yeah, this is moving here. You will see this is moving here. Okay. Now I will apply the motion analysis. Motion analysis, you can right click, toolbar, motion manager here. Here is the motion manager. You check it, it will come in the bottom section, motion study. Okay, I have this one, click this one, and animation, simply select animation. I am simply provide the animation, and you select motor, this one, motor, and give the select the face, this one, select this face, this one, rotation is clockwise, RPM you can give it, suppose 20 RPM you are giving. And you select the parameter from here, time for which, this one, hit right button and give the time for which you want the animation, 80 seconds. Okay, this one, you can also give the frame rate also from here, frame, suppose you give 25 frame rate. Okay, and this one. Now calculate, first it will calculate this one, you will see this one is calculated. Now you can play here, play from start, this one. You can reduce the speed also from here. Okay, in this way you can assemble the bevel gears. Bevel gears are actually used for the power transmission. When the shafts are, one shaft is this one shaft will pass from here, another is pass from here, so these two shafts will be at a perpendicular distance. Okay, but one thing is left which I want to some people don't understand, they clearly understand what is the mounting distance. Actually, if I take the normal, this one, this is suppose this one, and from here bottom down, and this one, and model, this is the model actually. Okay, if I take the normal, this one, suppose I take this view, this one, the straight bevel gears, and this one is show, this one. Actually these taper teeth meet at a certain points. Here you will see all the three. So mounting distance is from this end of the hub and this center point. This is known as the mounting distance. If you check it, evaluate, measure, and this one, this point and this point, you will see this is the 52 mm. Approximately I have provided 50 mm. I think this is the mounting distance. So this is the mounting distance. Mounting distance is the center point where these taper lines meet at a point from this point to the end of the hub. This is known as the mounting distance. Okay. I hope you would have enjoyed in my this exercise. You please like, share and subscribe my this channel. Thank you. Thank you very much. Thank you.